Okay, welcome back. So, procedure for simplifying fractions. We need factors. Let's see, 21 is 3 times 7. 49 is 7 times 7. So now we have factors explicitly shown. The way fraction multiplication works is that you multiply two fractions straight across. So if I want to go the other direction and unmultiply, I can certainly write 3 times 7 over 7 times 7 is 3/7 times 7 over 7. And then 7 over 7 is the number 1, which allows us to use the identity property and say, hey, that factor of 1 isn't doing anything. So as we move on and use the streamlined version, what we're doing is we're really, these, the 7 over 7 cancels as factors of 1. Okay, so we're just removing unnecessary factors of 1. Just want you to understand why we're able to do that. Okay, number 5, I see I already factored that for you. So that step was done for you. But again, the way fraction multiplication works, you can split off the common factors in their own fraction, which becomes a 1, and then allows us to use the identity property and simply not write the factors of 1 or the factor of 1. Okay, so I hope you understood what I was asking you to do, and you understand the principles involved. I'm going to go through it one more time with rational expressions, and that should give you some idea of how important I think this is. So again, the fundamental principle of rational expressions, and we'll use letters that sound more like names of polynomials. So this works with polynomials too. If you have a factored polynomial on top and down below, and you've got the same factor, you're going to be able to cross it out. So more simply, you're going to say P times R over Q times R is equal to P over Q. In other words, you're just going to cross those out. But again, the reason we're allowed to do that is because of the way fraction multiplication works. I can split off R over R into its own fraction, and then anything over itself is always a 1, whether the anything is a number or a polynomial or something worse. And then the identity property of 1 always kicks in and says if you multiply by 1, you don't change the identity of what you've got. So that gives us, this fundamental principle gives us a procedure for simplifying rational expressions, which is basically the same procedure for simplifying fractions. You're going to need factors, so completely factor both the numerator and the denominator. And then you're going to remove these factors of 1 by simply canceling factors common to the numerator and the denominator. For example, let's simplify 3y cubed over 6y to the 4th minus 3y cubed. So I need to factor. Now the numerator, that monomial, is already factored, but in the denominator we have a binomial that's not factored yet. It can be factored. So I'm going to use my factoring strategy, and I'm going to look for a GCF to take out first, and there is one. I can take out 3y cubed. That's going to leave me 2y minus a placeholder 1 there. And now I have a factor down below that's the same as a factor above. Now you may wonder, how can I call 3y cubed a factor when it's the only thing there? Well, you can think of it as multiplying 1, but it's certainly not having anything added or subtracted to it, okay? So it's not a term, but I can think of it as a factor. I'm going to cancel those common factors, and I'm left with this 1 on top and 2y minus 1 down below. We need to review a bit of vocabulary before we keep going. Let's make sure we understand the difference between terms and factors. Terms are things that are being added or subtracted, whereas factors are things that are being multiplied. So in the example we've just been looking at, if you look at the original denominator, 6y to the 4th minus 3y cubed, 6y to the fourth and 3y cubed are terms. Again, that's in that denominator, 6y to the fourth minus 3y cubed. They're terms because they're not multiplying each other, they're being subtracted. It's important to know the difference between factors and terms because there are different things that we're allowed to do with them. Now, after we factored that denominator, 3y cubed and 2y minus 1 are factors. That's not the 3y cubed in the original denominator. That's 3y cubed in the factored denominator, which was 3y cubed times 2y minus 1. They're factors because they're not being added or subtracted with each other. So the thing in parentheses isn't being added or subtracted from the 3y cubed. It's multiplying the 3y cubed. So those two things are factors. I know it can be confusing figuring out which things are factors and which things are terms. For example, a question I frequently get asked in this problem is, but aren't 2y and 1 terms? So I've just said that 2y minus 1 is a factor, but aren't 2y and 1 terms? Well, yes, they are, because they're being subtracted, but they're terms inside they're terms inside 2y minus 1. They're terms inside that factor, whereas 2y minus 1 as a whole is a factor. So you kind of have to keep in mind the context of what you're looking at. If I'm just looking at 2y minus 1, then I'd say, oh yeah, inside 2y minus 1, we have two terms. But if I'm looking at my factored denominator, 3y squared times 2y minus 1, 2y minus 1 as a whole is multiplying the 3y squared. So 2y minus 1 as a whole is a factor. Now, I want to caution you about a very common mistake, and that's why I've been so painstaking to talk about why it is that we can do this crossing things out. I want to point out a common mistake is to, right here, cancel the 3y cubed with the 3y cubed. And the problem is that this 3y cubed that I have there, it cannot be canceled. Why? Because it's not a factor. So I'll say yet, because eventually we cancel a 3y cubed. But this 3y cubed is, what is it? What do we call that kind of thing? Yeah, that's a term, not a factor. And only factors can be canceled.